Hello, this is Ashwini and welcome back to the new series of Recursion. And why this series is so special? Because I have done a lot of research, reading books and practice. After that, I have just write these notes and all because you can have better understanding after completing this Recursion series. You will not have any single doubt why we are using Recursion and why Recursion important. That's my promise to you. Okay, so without waste time, let me start this video. And you have one question in mind. Hey Ashwini, how we can get these notes? I will attach the link in description. You can download these notes from there and totally free. There is no cost, not a single rupee. Okay, so let us start this video. So you can have the something idea in your mind, right? What is a recursion is? So when you ask to your teacher or colleague, whatever, they will say the function call itself that call a recursion. Simple definition, right? That's true. Okay, and some in many tutorials I have watched on YouTube, they say like the function which call itself, but the recursion is which call and divide the task in a smaller chunk of pieces. That's called recursion, right? All the definitions, right? We are not talking about like which one is wrong and which one is right, but we will discuss about our nodes. Any function which call itself, it's a recursion, right? Yeah, basic definition. Now, a recursion method solve a problem by calling a copy of itself to work on a smaller problem. I think you haven't this idea, right? Recursion call itself by solving a problem in a small pieces, a smaller problem, and this is called a recursion step. Okay, this is a theory part. Just try to understand it because whenever we move into the coding part, we need a little bit theory because if you have remember that 10 plus 2 in physics questions, right? When we move to the physics question, before that we have read in a lot of theory, physics theory, like how the formulas work. So that's why I read these notes and I will give it to you because in future when you are preparing for our placements and all, this will help you. Okay, so now this is called a recursion step. Okay, recursive step. Now the recursion step can result in many more, such as recursive call. I will make you understand what is a recursive call is and what is a recursive step. Okay, it is important to ensure that recursion terminates. It is saying if some method calling itself again and again, that's a recursive step. Okay, try to understand it, and it should terminate, and definitely, because if the method is calling itself again and again, then compiler put that stack call, like call in a stack, and again and again if it's called, then it's called a memory issue. I will show you in a debugger like how it will cause a memory issue and how it will go to the infinite call. So we will not practice any code like which makes our memory leakage or memory issue. Not memory leakage, like memory will be full, like whatever the memory available for the stack, right? For calling a method, it will be full in a basic term. Now, each time the function call itself with slightly simpler or smaller version of the problem, okay? Because whenever a function call itself, okay, then it will call for a smaller problem. It is not a very when you ask or when you read in a book, it will say the function call itself so solve a smaller problem. But why it call? Because we divided that code and according to some logic we will see that. Okay, and the sequence of a smaller problem must eventually coverage on a base case. And a first line we here in a highlighter, it is recursion terminates. That the same thing here cover in a last line. The sequence of a smaller problem must eventually cover in a base case, where we terminate our program, that we call a base case. Okay, now the main important thing, recursion. Why we are using recursion, right? You can ask me, hey Ashwini, why you are using recursion? Is it possible to be all do the all codes of iterative solutions and all? Now recursion code is generally shorter and easier. I know we are using a recursion, then it will be a nightmare for me. When I was learning recursion in my early days, it will be a very headache for me. Like I haven't understand like how it is working. So generally shorter and easier to write a code as compared to your iterative codes. Okay. Generally loops are turned into the recursive function where they are compiled or interpreted. But it is saying second point, if you are writing your loops, that is the iterative approach. When you compile your code, it automatically get converted into the recursive calls or recursive methods. Okay, the main important point is recursion is useful technique borrowed from mathematics. How? When you are in 10 plus 2, there will be one theorem that is called induction, right? And that is a mathematical induction. What it says, like I need to prove that the sum of the first n natural numbers is I tends to 1 to n, and this is an equation, and n plus 1 divided by 2. Okay, we need to prove this LHS and RHS. So how I will do that? Like, put a n equals to 1, then you will get an 1 from this equation. Okay, then you put n equals to k, you will get a k plus 1 divided by 2. This is a normal equation. I'm not teaching you math here. Okay, right? Now n equals to k plus 1, you will get this equation. Now when you do, this is the equation I have formed because I want to prove that LHS is equal to RHS. And why you, like, I know whenever from here I am starting this concept of induction, you lose interest. I know this is a very different part, but my way of teaching is different because I want to make you understand like why and how the concept is used in a recursion. Okay, now this is a very important thing. That's why just listen carefully. We make a series from 1 to k plus 1. Okay, it means we want to calculate a sum from 1 to k plus 1. So here 1, 2, 3, 4 till k. So what is your k plus 1 divided by 2, right, from this equation? So it will k plus 1 divided by 2, k plus 1, and this k plus 1, and LHS is RH. When you solve this, it becomes LHS equals to RHS. Now what you get from this whole equation, let me tell you. This is the equation you put for any value, right? Like n equals to k, you get an answer, right, in an induction theorem. So what you will say, like, you get a k plus 1, you get an answer. You put a k, you get an answer. So from this theorem, you have to assume my function work before writing my function definition. This is a magic of recursion. If your function is work for, let me make you understand. If your function, let's suppose there is your function, right, and it is expecting integer n. Okay, and this is your recursion function, and your recursion function is working for n inputs, right? So you will say my recursion function is working for n plus n minus 1 also. So you have to assume if it is working for higher or any lower, okay, then it works for this kind of input also. So from this definition, we got to know, like, we have to assume. I know it is a bit difficult when you are, if you are starting your recursion first time. Now, one pro tip: while using recursion, we can perform operation in 3 ways. Now your coding part starts from here, okay? Because this is a bit different. Okay, I will not teach you recursion in that same manner. Okay, function calling itself, the 8-year, like 8th class boy also know what is the recursion and how the function call itself. Okay, because you are moving to the new era. Now while using a recursion, we can perform an operation in 3 ways. How? Doing a work while stack is building. Here the word stack is very important, just keep thing in mind, because the thing in recursion is all about your stack, how stack calls and how stack fall. Okay, now while stack falling, while stack building, and before a call, you can say that a work, this is a combination of second and first point while your recursion is building and while recursion is falling. Okay, now so this is an example, and I hope you are enjoying this course, okay, or this playlist. So we are starting a new fresh video from the example, and I will make you understand how the recursion works with the three, that stack falling or building, and doing a work before a call or after a call. Okay, so let me know in a comment section, like, is it helpful or not, or how the series is going. Okay, I will catch you in the next video. Bye bye. So let's understand how the stack is working, right? And why it is important to understand a call of recursions, right? Stack calls. So do not worry about it. Like, if you are new or if you are just starting your recursion, then I will make you understand each and everything. Okay, I just finished this theoretical part because I know this will be boring, right? Because you are learning a coding part, but this is very important to understand how the theory is. Okay, now let's understand what the first question says. You have to print a 5 4 3 2 1. Okay, and what is the code? I will not show you, because if you see the code at once, then the interest will be gone. Okay, Let me take you to the compiler or IntelliJ. Okay, what is your question is, you have to print 5 5 4 3 2 and 1. I hope it is visible to you. Okay, now let me write a program for you, then I will make you understand each and every point. Public static void. Why I am writing a void? Because I do not want to return anything from my method. Okay, and I will say print, and in print I will say integer. And okay, now from here what your work is, let me make you understand. Let me remove all these. Okay, your work is to print 5 4 3 2 1. Now as we have learned from your notes that we can assume after this theorem, because this concept it took from the mathematical induction theorem, right? So from this theorem, LHS equal to RSH, like we have some equation, then it will work for one input, then we can assume it will work for some higher input or some lower input if it is work for one input. In which cases, let's suppose you have a searching. In searching we do a steps, similar steps again and again. In sorting we do a similar steps again and again, right? So similar, if you found a task where you want to perform a work again and again, in that case you can assume, like if your code is working for one, then your code will work for other inputs, no matter it is higher or lower input. So let assume what your task is, to print a 5, right? Let me change that. What your task is, to print a 5, right? So you can directly say SOP 5. Let me write a code for it. You can say, Ashwini, this is very simple. I can do this, like system S out, what it is, S out, and you can say print f instant of print ln. You can say, Ashwini, this is very simple. I can say n. This will work, right? Now, but what happened if you say print n, then if you're like this is your print method, right? And it expecting an integer value n, and you say SOP n. So whatever the value you are passing, let's suppose 5, then it will print a 5. But I want this series, right? I want this series. So your method need to be called again and again. So I need to write that code. But this code is working for 5, and this is a value till here. This is your n, right? Total, this is a n, and this is your n minus 1. So let's assume here that your code is working for n, right? Then it will work for n minus 1 also. Yeah. So now what you have to do, I want to call my method, right? I just print my method. Now again call it, and in call what you have to do, n minus 1. Why? Because if you can see here 5, now your output will be decreasing, right? So now you can say, Ashwini, run the code. So I will just do one thing. I will print this and I will pass 5, right? Shall I run it? Yeah. You say, Ashwini, run this code. So let me run this. Okay. Now you can see my code is building. Okay. Still build. Passing data structure. It is the first project. That's why it's taking a time. But you can see what the error is, right? The error we are talking about in a first video. Recursion, and this will be error, and it's not getting stopped. So you say 5 4 3 2 1. Now let's understand this. You say here print n minus 1, right? Now your what happened here, let's understand the method stack. This is your main call, okay, and here this is your print. and here you passing print 5 n equals to 5. Again you are passing n equals to 4. Again you are passing n equals to 3. Again you are passing n equals to 2. Again you are passing n equals to 1, and again you are passing n equals to 0. Okay, so you can see it from here, right? It is doing your work. 5 4 3 2 1, right? You have given your code in that manner. Now if you ask me, hey Ashwini, this question is this code is right or wrong, I will say yeah, this question is half correct, because it is doing your work, but it is not doing a proper manner, because it is just extending my memory. Okay, so what is happened here, it is going out of memory, that's why the program got terminated. Okay, so here the stack will keep on growing, like n minus 1, n minus 2, like this. Okay, so what you need to do here now, right? We are talking about the recursive call should terminate it, so you need to put a termination case or base case. So what we will do, that you will say if n equals to 1, return, only return, because it is a my void method. Okay, so can you run this Ashwini once? Yeah, let me run it. Now it is building, and you can check the output. 5 4 3 2 1. I just mentioned the wrong here, 0. Okay, let me run it again. Not run with coverages, only without coverage. Okay, 5 4 3 2 1. Okay, let me hide it. I don't want notification. So you can check 5 4 3 2 1 is your output. Okay, now you can ask me, hey Ashwini, I haven't understand till now like what you are doing. No problem, let me show you the stack in very clear manner. Okay, first make you understand, then I will show you the compiler. So what you are doing, you have written a code. Okay, and what is your code is, and what is your stack is. So this is your stack. Okay, and this is your main call. This is your n equals to 5. This is your n equals to 4, n equals to 3, and n equals to 2, and this is n equals to 1, and this is n equals to 0. This will be your stack. Okay, let me show you. I will put my debugger, okay, here, and I have debug my code. Now as you can see here, this side, right, where I am just hovering my mouse, this is your main call. From here, this is your main, right? Okay, let me scroll down a little bit, and this is your method. So here the value of n is 5. You can check value n 5. Okay, let me come down. Now print 5. You can check the console, the value is 5. Okay, now again go here and value. Now you can check here, the stack is built main n equals to 5, n equals to 4, again n equals to 3, again n equals to 2, again n equals to 1. Now this is your base case. Now you can check here true, right, and it will come here return and came back. Now you can ask me, hey Ashwini, here you can check this all the stack, but at a one press, if I again do the next line, all the entries, all the entries directly terminated or directly removed from your stack. Like this will also remove, this will also remove, this will also remove. Not remove directly, it will come here, come here, come here, and removed, and it will go to the main and program finished. But in some cases, if you have a line after the line number 13, any code after line number 13, Then after the your first line, this first of execution, n number of, like n equals to 1, when you are calling a recursion method for this, your that line will be executed here. Okay, I will show you the next question, do not worry about it, but I do not want to miss any concept, that's why I'm telling you. Now if I say next, you can see all the stack is gone, only main is here, and I say yeah, that's over, and you can check your console. 5 4 3 2 1. I hope this is very interesting, and you know that like how we can, and how this is a stack building. Okay, and we have finished a first point from our notes. Okay, and you can check what we say, stack building, and you can check this code as same. And what I have written in this notes, let me tell you. N minus 1, let's assume my function is print n work for n minus 1. Okay, my repeated work is to print a value n, because I have tell you, right, you have to find what your repeated work in your code, in your question. So my repeated work, I have to print a value of n again and again, but in a decreasing manner. So that's why I pass n minus 1. You have to think little bit, right? Now, and what is my line says from here, the recursion should terminate it, as in this highlighter. It is important to ensure that recursion is terminated, otherwise it will go out of memory, because you do not have enough memory to do call a stack again and again, right? Because your method, all the method calls is stored in a stack by the compiler. Now, so that's why this point print n minus 1 is called a halt, because let me make you explain this also. What is a halt? You can ask me like, Ashwini, what is halt? Okay, so this is your track, railway track. Okay, and this is from your Delhi to, or somewhere we say Agra, and from here there are various stations, right? Now this is a station A, and this is a station B, C, D, E, F, G. Okay, now you can ask me here, Ashwini, this is a, what is this thing, right? Now it is a halt, not this diagram. Okay, I'm talking about this color. Okay, so this yellow color is a halt between A to B. The specific train, okay, will be like, suppose a train number 22604, okay, coming from Delhi to Agra, will be like, if train is going from here to here, one halt is between A to B and one halt is between C to D, will stop here and again start after this halt. The train will not come after it, right? After halt, it will go in a forward direction only. And here also, if train reached here at station C, it will stop at this halt, and let me name a H1 and H2. So it will stop at H2. Okay, and after a 5 minute, let's suppose it will stop for a 2 minute. So after 2 minute halt, it will go to the Agra, because yeah, obviously it will stop at D, E, F, G. It will the passenger, right? If it is express, it will not stop. Okay, yeah. So I hope now in terms of code, what is a halt is here. So I tell you, right, like when your program, when you press the next button, all the entries in from the stack will go away. It will direct to the main program if no code is available after that line number 13. Let me show you a code after the line number 13, right? So this is your halt. Okay, when you make a call from here, okay, each and every call is stored in a stack. But how your compiler know, like after completing this work in stack building, where you have to come back when you get your return statement, because you know that whenever you got your return statement, you have to go back to your caller method. So what is a caller? It is your caller, and it is become your halt when you call to the another method itself. Okay, so when you came back, compiler store a little bit some memory in like in the stack, like where we have to return back when we found a return statement. So it will came here, and start executing a line number 14, but we don't have anything. That's why compiler is a bit intelligent type person, right? He understand, okay, hey Ashwini, there is no line of code after this 13, so why should I remove all these text one by one? Let me remove at once only. Okay, so I hope this is a very informative video. Let me know in a comment section if you are learning something new from it. Okay, till then I will see you in the next video. Now doing a work while building a stack, it's completed, right? And second point is doing a work while stack is falling. Okay, so doing work when stack is falling. So I have already shown a code, but let me tell you what you need to print. 1 2 3 4 5. Okay, so let me go to the code and let me hide it and write a new code for you. So that is print public static and void and printing and integer. And so you, the same logic, you have to think your repetitive work, and your repetitive work is print, and the thing is you have to print 1 2 3 4 5. Okay, let me write a logic and make you explain. Okay, so same thing, you can say sys out. Okay, and 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 this time you need to add a base case, right? And what is a base case is and equals to 0. Always do like this, equals to 0. It will make more clarity to your code. Return. Okay, now this is completed, but your function call is not completed yet. So this time you have to put your function call like print t and -1. How it will make a difference? You can ask me, hey Ashwini, like how it is making a difference, right? You say this time like your function call above your print statement. So let me comment it and say print d and 5. Okay, because I want to print 1 2 3 4 5. So let me directly debug and show you what is the magic of recursion. Debug. So came to the debugging point. So if you check f and equals to false, right, it will not go into the return statement. Now if I say next line and equals to 5, again it came to the n equals to 4. Let me check you the, this is a n equals to 5 and this is n equals to 4, and it keep on going till n equals to 0. Okay, now it's our n equals to 1. So what is the difference in this stack building and stack falling is that here you are doing your work while your stack is building, but as you can check, your stack is built already, like your main, your n equals to 5 4 3 2 1 till 0. We haven't print anything in my console, right? But now your stack will start falling. You can check here like 0 and you say return, one entry removed, right? For n equals to 0 1, and you can see here now it will print something in your console, that is 1. Okay, again I will say after this completing this line, it will say again go to, because your program halted here, right? And when your that one stack is completed and when compiler remove your call, then it will go to the actual caller method, and after your caller this halt, you have this your line number 21. That's why it will execute it, because I tell you in a previous video, right, compiler keep remembering that before calling your method, like we have where we have to return. So next one by one your this all call is removing, and now it will go to the main and program completed, and you can check your output, that is 1 2 3 4 5. I think this is clear, right? Now I will see you in the next video when we are checking both the things, like doing a work with stack falling and doing a work with the stack falling and doing a work with the stack building. Okay, happy coding. Now we have completed doing a work when your stack is falling, so we only have a third point to understand, like how recursion is working. After understanding this point, I will move to the actual question, like Tower of Hanoi and all the other questions. Okay, recursion and all, like Fibonacci series. Okay, in recursion. Okay, so just please understand this one, and this is very important. So doing a work before a call or after a call. You can say in a second manner, doing a work like in building a stack as well as falling a stack. Okay, I will not show you a code this time. So I have written here what you have to print, like 5 4 3 2 1. Okay, and 3 1 2 3 4 5. So you can check from previous videos, right? This is a work when building a stack, right? When your stack is building, and this is a work when you can say when your stack is falling, right? Now do not watch this video directly. If you are not able to solve this question, then watch. Okay, otherwise just give a try once. Okay, now move to the intelligent. So let me write the code for you. See, so I have give a hint to you. This is a building a stack and this is a falling a stack. So now say I can write print d, or directly say print sequence integer n. Okay, and let me give the modifiers to it, public static void. Okay, now what I want to do, as out I need to print my n because this is my repeated work. And how will I achieve my repetitive work? You know that, right? How I do that? I will say print sequence and n minus 1. This is a way of achieving it because I need to go to my base case, and for going base case I need to decrease my input, or I need to make my a larger problem a smaller problem. I hope this is making sense, right? Not 1 0 return. Okay, now this is your a code similar to your first problem, right? You're doing a work by building a stack. Now s out again, and so if I run this code, the output will become directly, but I know that. Okay, so let me, what I need to do, comment it. Okay, and I will say print sequence 5. Let me show you the output directly. Run introduction. Okay, this is recursion introduction, that's why I choose this name, nothing else. So you can check 5 4 3 2 1 1 2 3 4 5, right? And now let me show you the stack. If you say Ashwini, I do not understand how it is working, so let me put a debugger to it. Okay, debug. So if you can check, your program came here for n equals to 5. Now on console 5 printed. Okay, now again it goes to n equals to 4, n equals to 3, n equals to 2, 1. You can see the console, your 1 is printed, 5 4 3 2 1, and your stack is built properly. Main 1 2 3 4 5, your 5 calls is here. Now you will call for a 0. Now it start removing the values from your stack, right? Calls, method calls from stack, and after this your halting point, you have write this line. And what this line is, when, yeah, there is a, here is a one tricky part. If you are understanding a recursion first time, you can ask me, Ashwini, here's a n equals to 5 4 3 2 1. The call goes in a increasing direction, like, sorry, right? And 5 4 3 2 1, and it is a like decreasing, like 5 4 3 2 1, right? And why it is coming like 1 2 3 4 5? It should come into the, like, in the direction it is goes. It's not happening in a stack. Okay, because what is a property of stack is, let me make you understand. Because compiler use a stack memory. Compiler use a stack memory, because you can ask me, right? This is a your stack, and here you are calling for 5 4, right? And 3 2 1, and here 0, and then it's false, it goes in this direction. but the calls when your return statement found, it come in this direction. So you can ask me actually why this is happening, right? Because the compiler use this guy stack, and it has a property that you say first in last out, leave like philo, whatever it is. Okay, so it is first in last out. Okay, so when it found a return statement here, it will go to the first one, and when this whole method execution is completed, it will go to the second one. Let me show you now where we are at n minus 1 result. So you can say here 1, but I say 1, so again 1 is printed. But after this execution is completed, it will again go to this line for n equals to 2. Let me show you. N equals to 1, right? If I press again 2 on n equals to 2, so it is going in this direction, this direction. Okay, so I hope this is making sense. Okay, so if I do again and again, okay, it will main and your program code is completed. I hope you enjoyed this video. You have any question, then comment it down. I will see you in a next video with some other more interesting question. With this video, the basic logic, theory, and all these things are completed, and we understand with these 3-4 videos how the recursion works and what is a recursion is. Now let's deep down into the recursion and do some tricky questions of GFG and leaf code. Okay. So till now we have completed all the operations, like how we are performing, like is while building a stack and while following a stack, right? So 3 type of operations we have covered here, right? Now, if you are following other YouTube videos, right, you might be having a confusion like Ashwini, they are telling in that manner, like function calling itself, like print calling print in this PDF, right? So, but let me make you understand one thing. I'm telling you the best way of understanding this, because believe me, if this is a 2 or 4 line of code, then this statement like for method calling itself will help you. But when you are working with to the big problem like tree and graph, this statement will not help you until unless you are not having an internal knowledge of how compiler put your method calls into the stack and how it will be moved. So now if you have once this method implementation or stack implementation knowledge, right, then you can solve any recursion question. Okay, so from this video we are solving a lot of recursion questions. Okay, so do not worry about it. If you haven't understand till now, do not worry about it. Okay, so now what is the today's question is, today's question is you have to find out the factorial of 5 and your answer is 120, right? I already told you. So let me write it down once more for you. Okay, what is a factorial of 5? That is 120. And how you can calculate it at that, you can calculate 5 into 4 factorial, right? Now that one important point I have told you while discussing these notes, like assume my function work before writing my function definition. So why I am just focusing again and again this point, because this is very important when we are working with the factorials, because you have to assume your function is already working, right? This is funny, but yeah, you have to assume your function is already working. Okay, first point, and you have to find out the repetitive work in your code. That's why when you make a relation of that equation, some kind of equation, then only you are able to solve the recursive problem. So I just assume like this is working for 4, then a 5, then it will give me the factorial of 4. But what is my variable? Sorry, my repeated work. I need to find out the factorial. So integer, and I will say here some kind of b and fact. Okay, so it is working for 5 factorial, right? Now I need to find out the factorial of 4, but it is already working. In that case, what should I do? I will do n minus 1. like in previous cases when we are printing 5 4 3 2 1, right? So we are doing n minus 1. Why? Because in that case we are assuming it worked for 5 and we are doing work for n minus 1. So here also it is working for 5 and we are doing work for n minus 1. Okay, and integer res. So what you will do now, and into here b, okay, and return res. This is your question, right? Okay, you can ask me, hey Ashwini, this is you can solve. Okay, I got it, but what will be the base case? So let me make you understand. So if you write like this, like 5 4 3 2 1, you are calculating till 1, right? Because 0 factorial value is 1. You know that. You read basic, you have basics, right? So if you tell like if n equals to 1, then return. And what you want to return? You want to return 1. Otherwise, if you return 0, then it will all become 0. Okay, so let me write a code for you, but before writing a code, let me make you understand the method calls and stack. Okay, so let me write, this is for main, this call is for main. Now let's understand this. This is very important. So you make this call, and you know that what I told you while discussing a nodes, when you are calling your method one entry, okay, compiler will make a one copy of your method with the variable you are using in it. So what variable you are using? N equals to 5, and b, in b you have this statement, in b you have this statement fact. Okay, it means it is a halt and it is a calling statement, so it's calling itself. So b is waiting to another call, that is n equals to 4, and b again, this is a halt and b is waiting to n equals to 3. Okay, and here again b, and it is waiting, right, to n equals to 2, and b equals to, b is waiting for answer because it's called other method, right? Not other method, it's calling itself, but is waiting to that return and give some answer. Okay, and n equals to 1, and here also b again waiting to n equals to nothing. Okay, this call will not happen. Let me remove this because we have put a base condition. Okay, now here you know that n equals to 1, right? This method calling will store in this, the compiler stored this method activation record in the stack, but whenever as soon as possible found n equals to 1, because the value is 1 here, right? So what it will do, value is 1, so what it will do, it will return a 1 here, but it will return 1. So as you can check, it will return 1, and what you are doing 1 here, what you are doing 1 into 2, and after calculation it is 2, so you are returning that 2 here. So what it will become, you are making a calculation here, 2 into 3, so it become 6, so you are returning that 6 here, so it become a calculation 4 into 6 equals to 24, so that 24 here, so what it is a calculation, it is 5 into 24, so 4 5 is 20, and it is to 120. Okay, and this 120 you are returning to your main method call. So this is your answer. I hope this is making sense, and this is a perfect explanation. Okay, because whenever you check any YouTube videos and all, they will not explain you this method stack. Okay, they will not explain because it is very simple to say like fact is calling itself, fact is calling itself, factor return, factor return. It is very simple to say, but this is an actual thing. If you understand this, then I can assure you, you will not have any problem in future. Okay, now let me write this code. So what we are saying, introduction. Now I'm making a new file for fact. Okay, let's make it, and I will say main, and let me write a function for it, dedicated function for integer and factorial. Yt is coming again and again, integer n. Okay, now let me write it fast. Okay, so what my work is, integer p equals to factorial n minus 1 Ashwini, and return, or let me write again, b result equals to n into b, or return res. Okay, and going for the base case, if n equals to 1, okay, return what, 1. So run it after calling from here, factorial 5. Okay, run fact. So what will be the answer? Okay, let me do one thing, cut and out, paste. Okay, and remove this, run. Output is 120, as you can see in a console. Okay, I hope this is something new you are reading, like learning from here. Okay, if you like this video, do subscribe and hit the like button, and if you want to ask something, comment it down, I will cover that question. Okay, welcome to the another question. So in this video, what we are discussing, find out the nth term of Fibonacci series using recursion. Okay, if I want to give a indexing, so what will be it, 0 1 2 3 4 5 6 7. Okay, and if you ask me, hey Ashwini, what is the like term, nth term, right? So basically the formula of nth term or this Fibonacci series is any, you can check the any item or any number, that number will be a sum of its previous two number. So if you say what is the fourth term, then it will be the 2 plus 3. So you can check 1 plus 2 is 3. So you can ask me like nth, n minus 1 plus n minus 2. So I want you to write a function that will return me a nth term. So that is public static integer and fib integer n. Okay, which term you want to take out, right? Now you, like what we have learned till now, I just assume this my function is already working, right? It is working for n. So this is a magic, right? Now what I want to do, like integer fib1 equals to fib n minus 1, integer fib2 equals to fib n minus 2, and return what it is, fib1 plus fib2. Perfect, because we already know the equation from this series. Like if you say what is the eighth term, then what is the sixth term, then it will be the 4 or 5 plus, right? So, but what will be the base case? You can ask me. So I will say you the base case is if n equals to 0 or n equals to 1, you have to return 1. I hope you are getting it. Like n equals to 0 and n equals to what, why we are putting a base case, right? Because as you can check the initial series, we are talking about nth term, right? So now let me write a code for you, and then we will discuss why this is a not good approach. Okay, so let's me go to the IntelliJ. Okay, so what I want to do, let me write a new class fib. Okay, and I will say here main, and let me write a function for it, public static void. Okay, and that is fib and integer 5, not no, fib, and it is integer n. And first of all, what I want to do, fib 1 equals to fib and here n minus 1, because I believe that my function is already working for which one, this fib 1, and it is integer. Okay, now integer fib 2, and it is fib n minus 2. Okay, and in return it is say this is only fib. Okay, fib plus fib 2. Okay, fib plus fib 2 and return. But base case very important, if n equals to 0, then we will say return n. Why? And here we have make a small mistake, let me correct it. So what it is, so we will say here only this one. Okay, and another one, it is like here I will write if n equals to 1, then return n. Why? As you can check the base case, if your 0 is 0, then return 0. If your base case is 1, then return 1. So we are talking about base cases. Okay, because we are making our input small. So if n equals to 1, return n. Okay, now let me run this after calling here fib 5. But before calling it, let me cut and paste inside it. Okay, and call, run this one. So the output may be a 5, because as you can check, the fifth term is your 5. Okay, now let's understand why this is not a good approach. Okay, I'm calling this for 5, right? So first call will be go to the 4, 3, 2, and as well as 1. From 2, like it will go to the 1, and once it return from 1, it will give 1, and it will go to the 0, and from 0 it will give it 0. So basically, when it finished, a second one is finished, 1 plus 0, it will give you 1. But once it is finished, like upper part is finished, another call will be here, go to n minus 2, it will be 1. Why I'm talking about n minus 2? As you can check this, that's why we are talking about those step calls and all, because this one will be keep on going, an activation record put in a stack. So once it will be completed, right, so again this call will start it. So that's why, let's suppose that third call is completed from here, right, so it will go to the now this one, n minus 2, right, n minus 2, here one call is go, and it will say what it is, like 1 1, okay, and from here it is 2, so you can return a 2 because 1 or 1. Again one more call is go, n minus 2, so this 2, and from here one call is given, that is n minus 1, that is 1, and minus 2, and 2 minus 2, it is 0. So as you can check here, what is output is, like here 1, here 0, and what is 2 is returning 1, so it is returning 1, so overall it is returning 3. Again we are talking about n minus 2, so it is 3, and again it is come, then one call is going, n minus 1, then 1, uh, 2, then 1, and no, n minus 1, it is 2, and it is 1. As you can check, again one call is go to 1, and again a call is go to 0, so it is 1, and it is 1, and it is 0, so 2 will return to it, and it is 1, and 1 return to 1, so basically it is returning 2, right. So this is 3 and this is 2, output is 5. Now you got it. But most important point, we just put n equals to 5, fifth Fibonacci term, but you can see 2 2 2, the same equation we are computing again and again, 3 3, right. So only the input n equals to 5, we are computing a 2, how many times, 1 2 3, so that's why it will become increasing a time, because execution is increasing, so execution increasing, time also increasing, so that's why this is a not good approach. We will enhance it and improve this in a DP videos. Okay, welcome to the another question of recursion. In this question we are solving like x to the power n. So basically what I want to say, like if we say 2 raised to the power 3, then it will be 8. And how it will, we are solving this in our second standard or third standard, like 2 into 2 into 2, it will become 2 into 4, and 4 to 8, so answer is 8. Okay, so this equation will help us to write a recursion equation, but first I assume this work for n, and it should work for n minus 1 also. That basic we are learning from video 1, right. So how I will write my that statement, so integer res, and I will say x into, why, because we are into like 2 3 times, then only my answer will come, right. So x into power n minus 1, okay, and what will be the my base case, if n equals to 1, then return x, okay, and you can return res. You can say me, Ashwani, I don't understand how it is working, so let me make you simpler this for you. So this is your tech, okay, this is your main, okay, and this is your equation, x into power, right? So for power I'm writing p for 5, and here x, and it is p for 4. Okay, let's suppose I'm passing n equals to 5 instead of 3. Okay, I'm taking a bigger value for you. Okay, and x equals to x into p equals to 3, and x into p 2, x into p 1. So as 1 will come, so now what will be the output? Like x, what is the value of x? I'm passing x equals to 2 and n equals to 5. So 2 raised to 5 equals to 32, right? So x, so x value equals to 2. So what will be the output? 2 into 1, because I writing a base case, it n equals to 1. Okay, so now here it will return a 2 here, so 2 again into 2, so it will become 4. So here 2 into 4, 8, again 2 into 8, 16, again 2 into 16, 32. Done, right? I hope you understand this. Now let's go to IntelliJ and write this. So let me take a new class for it and say power, and let me write a main, and I will write directly here power, and I will pass here 2 and 5. Now it will ask me to create a method. I will say import not this power. Okay, let me create my one, public static, and it will return integer, and I will say power integer, this will be x and integer n. Okay, now integer res equals to x into, where it is, into power, what it is, x and n minus 1. I hope you got it, and res. Let me go up. If n equals to 1, then return what you return, x. I hope you understand this. Let me cut this and s out and paste it, and I can remove this. Now let me run this. It should be 32. Okay, 32. Okay, I hope you understand this. Now next question is, check if array is sorted or not. GFG, easy question. Okay, the company tag is not available under it, but it is a recursion. We can solve this question as a recursion and easy question. That's why I just included it. Okay, so what's your question is, this is your array. Let me remove this one. Okay, this is your array. You need to check is it sorted or not. Okay, so basically what is your n is here. If I give you n value, so your n is 1 2 3 4 5 6 7, because n number of element. So let's check the code once. I have write a code here and make it full screen, and this is a base case. So here I assume my function is already working for n, so it will work for n minus 1 also. Okay, now what operation I need to perform? This is a base case, and why I write n equals to 0 and equals to 1, I will let you know. Okay, just wait a minute. Here this is a condition. I'm asking this like n minus 1 and n minus 2. You ask me, Ashwini, hi, why we are doing this? Because in iterative approach we are traversing our array from 0 to 1, 1 to 2, 3, 4, 5, like this. Okay, 6. And but in from recursion, through recursion we are traversing from backside like this, because we are playing with the number of element is given this method. Okay, as you can check here. So there is a one catch. If you see here, n equals to 5, right? And how many element are here? 5. But indexing of element is start from 0 to 4. It will become 0 to 4. So that is the reason I'm passing this n minus 1 here. Okay. So what is this? N minus 1 here. When you pass n minus 1, it will start from your end. And here we are using n equals to 0 and equals to 1 because we are checking the two element at a time. Like I'm at n minus 1, I'm checking n minus 1, like fourth element. N minus 2, I'm checking third element. N minus 2 and minus 1, why I'm doing? I hope you understand it. Let me show you again. Because if I do n minus 1, then only I'm reaching to the fourth element, this element. If I do n minus 1, then only I am reaching to the 17th element. If I do only n, then it will be a array index out of bound. Okay, I hope this is making sense. And if you don't understand this, just make a stack trace, which we have learned in previous videos. You will get to know why we are doing this. The simple, this is not complex anything here, just the numbering starting from 0 to 0, and here it giving a direct number of element. That's why we are doing n minus 1, and it, and assuming it's working for n, the simple solution, right? Okay, so what is the next question is, like there is a one question on GFG. You need to find out the first occurrence and last occurrence, but I have manipulated this question because I want to solve the first easy part, then I will move to the like a second part. Okay, now here the array is given, and what is the common in this array? That is 2, right? Occurring 2 times, 1 and 2. So you need to find out the first occurrence, like where it is occur, and you need to print the 2 because the 2 occurred at element at index 2. Okay, so if it is confusing you, let me give you the another example. Let's suppose you are having 6, 5, 7, 6 and 8, 9, and I want you to take out the occurrence, first occurrence of 6. So what is the first occurrence of 6? That is 0. I hope you understand it. So let's go to the IntelliJ and code it. Okay, so I have make this method. You can make any type of here your declaration. Okay, so what it is, I'm taking an array and integer x the element, and from which index I need to start my array. Okay, now what is your here, if I make you understand what is your repetitive task, like from the first minute what we are doing here, we are finding our what I am doing a repetitive task, and what is my smaller task, what is my smaller one. So smaller, why I'm saying smaller, if your method is working for n, it should work for n minus 1 also, right? So here your method is working for this. What is your working? You need to check each and every element from the array. Is your x equals to arr of something here? Okay, you need to check this equals. So if your method is working for n, then it should work for n minus 1, right? It will check for, if working for n, it will work for n minus 1. Okay, I hope you are getting it. And what is a repetitive task? You need to check the things again and again. I hope you are getting all things. Okay, so let me call the method for n minus 1 because you already called for 1. So find first and arr, and your x will be x, it will not change, and I plus 1. Okay, yeah, this will help you to call your method again and again repeatedly. Now what is my repetitive task? That I need to check my x equals to arr of I. Okay, if it is true, then return of I. Now what will be the base condition? Let's suppose your method is like I am searching, your someone putting here x equals to 10, x equals to 10. So your 10 is not available in your array, right? Your 10 is not available in array, so you need to return a minus 1 in that case. Okay, so that will be your base case. So if you will say your I equals to arr dot length, right? In that case return minus 1. I hope it is making sense. Okay, now what you need to do, return, just hold this thing in something like integer res, so you can return it. I can directly type a return here, but as you are starting a recursion, and it will be I don't want to make the confusion for you. Okay, so recursion and semicolon. Now let me call this method after creating a array. So integer uh, arr, and I directly initialize here. So what my array is 657 689. So 657 689. Okay, and let me call it sop sout and find arr, and I need to take out the first occurrence of 6, and I need to start my array from 0. I hope it is making sense. Now run. So it is occurring at 0, so my output is 0. Okay, I hope this is making sense, and if you have any question, just let me know in the comment section. Okay, now moving to the next question. So your next question is like, if, yeah, I told you, right, there is a GFG1 question, first occurrence and last occurrence. So I just break down this question in two questions, like first and last. So here we are solving a last one. Okay, yeah, so in this question we need to print out a last occurrence, and the answer is res equals to 3. Why 3, you can ask me. So I can say like 6, my x equals to 10, right? So 6 is occurring here first time. So in our question the answer is 0 because it is a first index, and here the answer will be 3 because x equals to like occurring at a index number 3. Okay, so I hope you understand it. So let me make you understand through the code. If you not understand, then let me know in a comment section. After the question, why I haven't explained you this stack of this question, because I am waiting for this completing this question. So after completing it, I will explain you the stack. Okay, how the stack is forming and how this is working. So let's go. So this is the first index, right? So I will just code another method below here and copy this and paste it. Okay, for instead of saying first, find first, I will say find last. Okay, and just remove this. Yeah, same signature, just I need to find out the last one. Okay, yeah. So now what is a repetitive task? Again, as in previous question, I need to check and if my method is working for n, and it should work for n minus 1. So let's do this. Call for method for n minus 1 first. So arr, and your not first, last, buddy. Yeah, arr, and here x equals to your 6, and no, only x and I plus 1. Now as you remember in your first questions, we are doing our work while our stack is building, right? And we are doing our work while stack is falling. So this is our work when stack is building, right? Let me give you the example. Okay, now what do you need to do? Just integer res, just hold it answer somewhere, and what you need to do, just call it. Okay, just call it. Now here, when let's suppose you are calling these all methods, okay, and you need to just print a base case here. You need to write a base case. Like what will be the base case? You know that, right? Like if your I equals to arr dot length, then you should return -1. Now let me explain you the stack. Then this will be a very clear picture. Okay, so let's suppose this is your stack. Let me take this one. This is your stack. Okay, and in stack you are, this one you are calling for find last. So I will directly say here fl. Okay, I will not write a full form. I will say find last, and you are passing your array and your 6 and your x and 0. Okay, and again you are here, again you are calling and waiting for the result. So res goes to this, and again you are calling this one. Okay, again stack is building, and this is for I equals to 1. Again you are calling, right, and this is for I equals to 2. Again you are calling, and this is for I equals to 3. Again you are calling, this is for I equals to 4, and again you are calling, this is for I equals to 5. And as soon as possible your I equals to 6, right, I equals to 6, then your base condition, that is says I equals to 6, right, your I equals to 6. Let me write it again. I equals to 6, then you will be written -1. Okay, last index. So in this case, what you will check last index, if your this answer is -1. Okay, if res equals to -1, then you need to check, like, if arr of I, okay, because now you are at lower index equals to x, then return, in that case you need to return your I. Okay, else return -1. Okay, now let me return res. Let me run this code, then I will make you explain the stack. S out arr 6 0. No, find last arr 6 0. Okay, now let me comment this down and let me run. So the answer is 3. As you can check here, the answer is 3. Now you can ask me, hey Ashwini, how it is working. Okay, so I'm doing a work while my stack is falling. Okay, so you can have one idea after solving this many questions how a compiler removing your entry from the stack. There is two way. Either in your execution you will found a return method. Okay, this is only one method, but my analysis, okay, I'm telling my analysis, but compiler remove your like your entry from the stack, only it will found a return. Okay, if it only found a return statement. Now but my one analysis says there is a two ways. One is your return, and second one is when the last curly brace is found. Okay, that is also possible, right? Now what I am done, I just make a call again and again, and here at I equals to your 5, it is I equals to 5. After it I'm checking here, the result is -1. Okay, then I am checking at 5 if array I equals to x. So f in your 5 is 6, no, then I'm returning -1 again. So here now it will go to the index 4 here and check again. It came here -1. This is also false, again returning a -1. Now again check to the 3, again came -1 and equals to, yeah, it is true, and it is come to the I and I'm returning a 3. Now this condition will be false for all the recursion calls that are falling from the stack. If you're not understanding this, please backward your video, you will get it what I am saying. Okay, if this is not possible, let me run the program in debug mode, okay, and make you understand again. Okay, as you can see here, now as you can check here, I will be increased. Okay, 2, 3, 4, 5, 6. Now it will be terminated and return -1, and -1 come here, okay, in res value. So what is your res value? Okay, and not this is arr. Your res value will be -1. Okay, you got it now. But I value will be 5 because your stack entry, this entry removed after the return statement, and you return -1 to your 5. Okay, now came back and return -1. This will be a false. This is a false because I'm checking here like my data. So -1, again -1. Now 3. This condition is a true condition, and 3. Now this upper condition is not true for all the stacks which available, because I already set my value once, that is not -1. Okay, so now if you can check, this false, again false, again false, again false. I hope you got it this. Okay, now moving to the next question.